Hello, everyone. I'm Zhang from Microsoft Linux team, and I'm working on the paravirtualized features on guest Linux in Hyper-V. So my topic is Hyper-V-based pvIOMMU using JSON's generic LPT. Yeah. So this work is done by me and my colleague Jake and vSVA, I think, who is also online, and. So I would like to give some design choices of our pvIOMMU driver and the generic workflow, its current status, and most importantly, some opens. So if you have any question or suggestion, please raise your hand and feel free to chime in. Thank you. So the primary goal is to enable virtio-iommu inside the Linux guest on top of Hyper-V, so that this virtio-iommu can provide some like three fundamental functionalities, like in-kernel DMA isolation, enabling of user space drivers based on VFL and IOMMU and some advanced features like vSVA and virtual PRI. And this driver should fit into the IOMMU core system elegantly. But we do have some, more ambitious goals, maybe. So we want to make our IOMMU driver to be vendor agnostic, or maybe even arc agnostic as much as possible. And we also would like this driver to maximize its performance by fully utilizing the IOMMU hardware enhancements. And based on these goals, we have made several design choices. The first one is PV versus emulation. Yeah, we choose the paravirtualization because in Azure Cloud there are many different types of IOMMU hardware, like VTD, AMD, and SMMU. So it could be quite a lot of work for our hypervisor engineers to provide the full emulation for each type of IOMMU hardware. Oh, thank you. Yeah, so another reason is that we believe with good abstraction, paravirtualized IOMMU can at least achieve the three basic functionality with minimal code change. And another choice is we want to make use of nested translation instead of sending map and unmap requests to the backend. So yeah, there is performance benefits without trapping of map and unmap. And yes, we know that with nested translation, that means a guest need to send the hypercore to hypervisor to perform the LTRB flush and possibly the device TRB flush. But for that hypercore, we argue that this LTRB flush can be lazily and can be done in batch. And also we admit that if the LTRB misses, yes, nested translation requires more page table walking. Yes, so we will maybe perform more evaluations. And another important reason we choose nested is because the consideration of page table memory accounting, which is a requirement from hypervisor. So if we use map and map trapping, that means Hyper-V will have to create separate domains for each guest LVA domain. So meaning a combined translation shall be created for each GLVA into HPA, and the guest can maybe ask for many different GLVA domains using the host memory. So that's something we do not want to see. And also, we use the nested because we believe the ecosystem is ready. So most hardware IOMMU has supported the nested translation. And also from implementation point of view, thanks to Jason, we have the generic IO page table, so we do not have to cook another page table management code in our pvIOMMU driver. And also we start with just supporting one pvIOMMU for each guest. Another design choice is about enumeration. So by enumeration, I mean the detection of this virtio-iommu, its presence, its capability, and the device scope it covers. So for now, all the IOMMU driver uses SPI table, like DMAR for VTD, LRT for SMMU, and even VIOT for the virtio-iommu. But we choose to use hypercore-based enumeration because, we just want to avoid the need to the spec change and the need to modify the virtual firmware. As you can see from the right-hand side, there are two hypercore output. The first one is used to check the presence and capability of this pvIOMMU. It's only a common IOMMU feature set. There's no vendor-specific capabilities. And for the second one, the get logical device property, it's only used when the endpoint device is being probed to check whether this endpoint device is supposed to be managed by the virtio-iommu. So we do not need to provide any data structures like device scope in the DMAR. So I hope this choice is acceptable. This is a general workflow of this pvIOMMU. As you can see, we have talked to the two hypercores. Okay.
So this looks very similar to what we are doing in pkVM. I don't know if you're aware about the Google data pvIOMMU driver as well, which is basically pretty much we are calling hypercalls and taking up SMMU v3 driver and then doing that for the same thing for the guest. And not sure it's there already, again, not in upstream maybe. And that's pretty much what is being designed for the guest. And Qualcomm does it a little bit differently under Ganya. So we were, for SMMU v3, we are exploring more of a virtio-iommu. For the host side, even not doing a complete nested stage translations. But again, we are more inclined towards now more stage 1, stage 2, kind of doing a trapping and emulating because of performance and maybe things are getting improved on SMMU3 hardware side. So, but not sure if it is a duplicate kind of stuff we are doing or if you are aware about it. So there's already work done there. Maybe not common framework like you are trying to achieve, but maybe there is something there. So in ARM case, at least.
Thank you. By the way, so are you using the only ARM specific?
It is SMMU3, so yeah.
Yeah. So you are actually paravirtualizing in the SMMU driver?
Yeah, for the case, we are pretty much using the
So any reason you did not use virtio-iommu?
Yeah, so that's where I think Google's, I don't know the original reasons, but they started with the kind of not using virtio-iommu because we just want to have a hypercalls into the hypervisor itself rather than coming back to the host and then doing all of that. So.
And those hypercalls are into KVM?
pkVM, basically.
pkVM, okay.
Yeah.
Okay, thank you.
I can send you the link.
Thank you.
I think
Yeah.
Yeah, we're also looking into x86 pkVM, and we are looking into pvIOMMU on that platform as well. So I think we need to talk.
Thank you. Yeah. So by the way, so for pkVM in x86, are you trying to paravirtualize in the VDD driver?
So we trying to do what ARM does for pkVM, but because x86
But x86 is different.
it is.
The root, non-root are.
So we essentially virtualizing the host OS and using, I guess, virtualization to achieve the isolation.
Mm-hmm. So, are you also trying to use nested translation? I guess so.
I'll have to connect you with
Thank you.
with my lead to
Sure.
to give the details.
Sure. Thank you.
the latest version that Mustafa posted for PKVM for ARM has given up on the, I don't know, the sort of paravirtualized like you're doing, and the PKVM is just providing a paravirtualized SMU v3 hardware model directly, and it's using the normal SMU v3 IOMMU driver. I strongly encourage them to do that, and in fact, I strongly encourage everyone to do that, because all of the hardware people that have implemented nesting have thought it through enough that it's designed to be paravirtualized directly, and you'll get a better result because so much of the hardware detail leaks out that by the time you get like a virtio IOMMU or something that can deal with nesting, you've basically just duplicated your driver 3 times, because all the invalidation logic has to be exactly the same, and it's all incompatibly different. All the passive logic is incompatibly different. Things like the GCRE versus the CD table are incompatibly different, and they all leak out to the guest.
But Jason, your suggestion is only for ARM SMMU?
No, all of the platforms.
And the reason is, I mean, ARM has very specific LTLB flash requirement, like you mentioned, but for x86?
x86 has a different flush command than AMD does, and a different flush command than ARM does, and a different ATS command than either of the two of them, and so forth and so on, and it leaks out. You have to, especially if you want the AMD and ARM have options for guest-controlled command queues. So if you want to expose that performance feature as well, then you're duplicating the entire command queue logic now from all the native drivers, and it's just, there's no reason. You don't get it.
That's something we want to discuss maybe.
Yeah.
The virtual command queue, yeah.
I would like it if you explained why Microsoft thinks that they want to have a common virtual IOMMU driver instead of using the existing hardware drivers. Like, I think that's a really key thing to articulate.
That's a question about whether to use PV or emulation, right?
It's all, sure.
Yeah. So because we are using Hyper-V.
Unless the hardware has some trouble and they do not have like direct command queue kind of support in the case of ARM, where okay, hardware is lagging and you will see some sort of performance issues or something because of trap and emulate everything.
Well, currently the only vendor that has actually published direct command queue is AMD.
There is ARM word difference, but we can talk about it.
And NVIDIA's proprietary for ARM is published.
Yes.
And
it went into the specs now.
Yeah, and then ARM is doing something that we can't talk about, right?
Yeah.
So.
Just online question, 1 second.
Go ahead.
How do we answer this?
Okay, so
Yeah.
is that a call for the remote? Yeah,
Yeah,
Jason, I was wondering if your recommendation for everybody to use the internal drivers is specific to KVM, or does it like regardless of hypervisors?
Yeah, I think it's just
Because
a general
like that.
recommendation. Yeah, if you want to do nesting, if you want to use nesting hardware and with IOMMU, then the guest driver, I feel, is best to be the native driver.
Well, I think other than the hardware acceleration, the command QV, we have yet to see, I mean, like the emulation logic has a lot of overhead, right? I mean, compared to PV. And also when you optimize the driver, you're not going to consider how many VM exits are going to cost, right? So the optimization of the bare metal driver may cause counterproductive effect on the, on the emulation. So by doing PV, everything is abstracted out, and that can be more.
Almost.
Yeah, something, but
Almost.
Very little.
yeah, I guess we haven't yet to see invalidation being such a, critical factor, especially for IOVA, so mostly lazy, batched invalidation, other than
SVA,
Yes.
validation performance is critical.
Yes, that's maybe you has a slide.
Yeah. So next page. Maybe. We can just move on first. Okay, this is a general workflow of this pvIOMMU, and those are the hypercores we have introduced. As you can see, there's no trap for the map and the unmap, and we are using LTRB flash hypercore, and for now we are using domain selective LTRB flashing, but we do have new hypercores to be introduced to do this page selectively. And the status, I have sent out the patch of GLV support earlier this week. Sorry, I think I forgot to CC to some of you. So Jason, Alex, anyone. So I'm sorry, but please forgive me and please help us review. Yeah, and for the GLV support, we have finished the POC, and hi, I think there's another question.
Can you hear me?
Yeah.
Okay. My question is, what's the comparison between the virtio-iommu and your pvIOMMU? I mean, what's the advantage?
So So currently, virtio-iommu, their upstream code is actually based on the map and the map request to the backend. That means for each map and the map, it will have to trap to the host. And I think Jean-Philippe is trying to propose a page table-based virtio-iommu, and I'm not sure if Zhang is on. Zhang.
Internally, we have expanded the virtio-iommu driver in our system, in the RISC-V system, and we have added the user log domain. We have added the nest log. We have added user domain. So actually, it didn't pass through to the backend. It can directly map in the support nested translation in the gas.
Yes, it can.
I think this is not a reason. So do we have other advantages beyond the file?
Actually, we also have some prototype based on virtio-iommu using also Jason's generic LPT to construct a nested translation. And we have not sent out the patch because virtio-iommu spec is not finalized in the committee. So I guess, if it is finalized, I think it's also okay. But by the way, Hyper-V does not have a virtio. So that's why we are introducing a Hyper-V hypercore-based one instead of extending the virtio-iommu.
Am I here to ask you?
Yeah, I think I'm almost. I'll be quick. Thank you. So opens. So one of the open is that we want this driver to be vendor agnostic. We have Jason's generic LPT, so we don't have to provide ARC-specific page table management in the PV driver. But we are wondering if there's any requirement or any plan to offer a generic capacity table, no.
Use the real drivers, right?
Yeah.
The list encapsulates why I'm telling you to use the real driver.
So, yeah, we do not want to use that driver, but yeah. So what about we offer one? Yeah, okay. So, and also about the hardware acceleration, so for the virtual command queues submission. Yeah, okay. And also, yeah, about the adoption, maybe any requirement from the virtio-iommu side. So if yes, maybe we can collaborate. So that's it. Thank you.
Okay, thank you so much.
Any more questions?
One question is.
I'm sorry.
Do you think?
Sorry, Google, please. We don't have time.
Yeah, we can discuss offline.
You can take it offline,
Yeah.
please. Thank you very much.
Thank you.
Thank you.
Thank you.